Hi, my name is Mark Zachary, and my teammates are Esteban Ramirez and Bonnie Mahajan, and today we'll be presenting Drum Playing Robot. Our motivation behind this is having machines play instruments is a reliable way of achieving an accurate performance while keeping the natural acoustics of the instrument intact. The study of a robot capable of playing percussive instruments can be particularly insightful, as it brings forth many of the problems faced in the robotics industry nowadays. So here's a little sneak peek into what the final version looks like. And here are the steps that we took and the challenges we faced to achieve this system. First, we needed to add a drum kit, build the environment, and add two arms to it. Then we needed to figure out a way to process the MIDI files and how to ingest those. Next, we had to figure out the trajectory of each arm, as well as which arm should go to the next hit, and translate the velocity of each hit into the wrench applied by the robotic arm. We had to make sure the arms don't collide with each other and manage the interactions between the sticks and the drums, and we'll dive deeper into each one of these. First, adding a drum kit. We used an SDF format to create two models, the drum kit model and the stick model. We've simplified the drum kit model to the major 7 pieces of the kit. We added hydroelastic collision to better simulate the interaction between the stick and the drum kit. We then welded the drum kit to the world so that we can ensure the kit stays in place when in contact with the sticks. For the stick model, we added bounce to its collision geometry to better simulate the recoil, and then we welded it to the EWA arms to simplify the simulation and ensure it doesn't fall off. And here is what it looks like. As you can see, we have the simulated 7 drum kit pieces and the 2 EWA arms with 2 drumsticks attached to it. And here are the collision geometries as well.
In order to simulate drum playing on Drake, it was necessary to use some representation of drum hits in numerical format. We decided to use this MIDI file format, which is an industry standard for music-related information. These files, containing data about music events, were used to determine what should be played and at what time, and how strongly they should be hit.
For trajectory planning, we experimented with 2 techniques, inverse kinematics and kinematic trajectory planning. In inverse kinematics, we simplified the process by assigning the left side of the drum kit to the left arm and the right side of the drum kit to the right arm. We experimented with positional constraints defined by the geometry of the drum kit, and we experimented with minimal distance constraint to prevent collisions. This technique was capable of efficiently finding desired end effector position and orientation, but this technique was limited by the lack of trajectory information provided, and we were also unable to set final velocity of EWA arms, thus failing to achieve our goal of also simulating the hit velocity of each hit. However, in trajectory planning, we used a similar process with similar constraint, but we were able to add spatial velocity constraints in this method, and multiple iterations of no collision constraints along the B-spline path of the trajectory, which worked much better. One of the biggest challenges we ran into is that we had to experiment a lot with the number of iterations along the path, and the speed of solving the optimization problem was relatively slower. And here we have 4 different videos of some of the challenges that we ran into. So the first one is just being able to control 2 EWA arms, and the way we solved that is we assigned the left side of the drum kit to the left arm and the right side of the drum kit to the right arm. The second video on the right, we have examples of the EWA arms colliding with each other and the drum kit. On the bottom left, we have some of the problems with just using inverse kinematics. Essentially, it just knows the end effector positions but doesn't plan the trajectory along the way. And on the bottom right, we have some of the velocity control that we had to do, and a few experiments with the bounce. And as you can see, there is a recoil, just how you would do it in an actual drum playing. And here are some bloopers.